Hi, I welcome all of you in my channel and in this video in which I am going to manually solve a question based upon z-test with two-sided hypothesis. In this question, first I will formulate a hypothesis, then test statistic. Based upon the test statistic, we will conclude and will interpret the results. After that, I will calculate the p-value of this question. So let's start the question. The viscosity of liquid detergent is supposed to be average 800 centistoke at 25 degrees centigrade. The random sample of 16 batches of detergent is collected and average viscosity is 812. So our stated value or mu naught value is 800 centistokes, whereas the value which we got from our sample is 812 and it is said to be y bar in the sample. Suppose we know that the standard deviation of the viscosity is sigma is equal to 25 centistokes. As in this question we have the value of the standard deviation sigma, so we will use a z-test. Further, there is only one sample data has been provided, so we will use one sample z-test. Further, in this question there are no words such like exceeds, less than, or greater than, or you can say or at least. So these words are used for one directional hypothesis. However, if there are no such words used, you will be confirmed that we will have to use a two-sided hypothesis. Means there will be the sign of inequality in our alternate hypothesis. Let's start with the null hypothesis and alternate hypothesis. The null hypothesis is represented by H0, whereas alternate hypothesis is represented by H1. These are the few cases that have been presented in the book for the z-test scenarios. So we are following this first one, that mu is equal to mu naught value is 800 and mu is not equal to mu naught, and rest of these two scenarios, this one and this one, these two scenarios are related to directional hypothesis. However, the z statistic value is same for all of them. So I have written mu is equal to 800 and alternate hypothesis mu is not equal to 800. Please remember that we'll never write here the value of the sample mean. That is, in this case we got 812 from our sample mean, so we will not write here that value in our null or alternate hypothesis. We will always write our stated value. So this is the test statistic value. We will compute it from this formula. Now I will write the values that have been provided to us. Sample mean 812, stated mean 800, standard deviation 25, and the sample size was 16. I will put all these values in this formula to get the z0 value, test statistic value. And the z0 value it come to be 1.92. The next step is to state the rejection criteria and the computation of z alpha. The rejection criteria associated with two-sided hypothesis is absolute of z0 value. If absolute of z0 value is greater than z alpha by 2, then we will reject the null hypothesis. So I copied the rejection criteria from that slide. After that we will have to compute alpha. So I have taken alpha is equal to 0.05 in this case. We need alpha by 2. So I will divide this alpha value by 2. 0.05 divided by 2, this will be equal to 0.025. So I need the value of, I need the value of c 0.025 from the z distribution table. I have drawn the figure of the normal distribution. Then there will be two cutoff regions, both are at lower tail and at upper tail. Now I will have to compute the values that will be used for the cutoff region. So one of the z alpha value will be there and the second one will be there. As you people know, we have a center in the normal distribution. Along the left hand side of this center value, we have all z negative values, and along the right hand side of this center value, we have all z values as positive. So For this alpha by 2, we have 0.025 probability. On this lower tail, we will go to the z tables with the negative z values, and we will check here the probability of 0.025. And the value which we will get, so we will just have to change the sign of that z value, and we can write it there. It's right here that z modulus of the z naught is greater than z 0.025. This value will be obtained from the z distribution tables. Let me tell you one thing more. The values, so this is basically over 2.5% probability. So quite obvious that it will lies on the left hand side of the probability, and if when we pick up the value of z alpha by 2 from the table, it will be a negative z value. However, due to symmetry, we can write that value with a positive sign on the right hand side. Let's move towards the tables. So you people can see here that the probability of 0.025 is associated with the z alpha by 2 value of 1.9, and with this row and this column is 0.06. So it comes out to be minus 1.96, and whereas it's 25% 2.5% probability, and on the right hand side there will be a probability of z 0.975, and it will be equal to 1.96. So due to this value, I have written alpha by 2 is equal to 1.96 and negative value, and positive 1.96. Now we will talk about our rejection criteria. We will talk about interpretation of the results. So as our computed value 1.92, it lies in between these two extreme points, positive 1.96 and negative 1.96. So therefore it lies somewhere here. So z naught is equal to 1.92. It lies in the good region. So we say our rejection criteria is not satisfied. 1.92 isn't greater than 1.96. So the rejection criteria comes out to be false. Therefore, the criteria is not satisfied. We fail to reject our null hypothesis. Now we will talk about the computation of the p-value. Again, the computation of the p-value expression has been copied from there. P is equal to 2 multiplied by 1 minus the probability associated with the absolute of the z naught value. So z naught value, I have put the value of z naught in this expression. Now we will have to check the probability associated with the 1.92. The z value is positive. We will only look this value in the positive z tables. So in the positive table, you can see there is 1.9, and in this row, if we come towards 1.92, still here, so that is 0.9726, because we can see in the top row associated with it, this value is 0.02. So it comes out to be 1.92. The probability, I will copy it from there. 1 minus 1.9726 comes out to be 0.024, and when we multiply it by 2, we got 0.055, that is greater than 0.05. This is our alpha value or cutoff value, significance value, you can say. What will be our final conclusion? That the average viscosity of the liquid detergent is found to be 800 centistokes at 25 degrees centigrade. Hopefully you've liked this video. If you have any question, you can ask me in the comment section, as well as you can WhatsApp me, email me your problem. I'm available for your consultation. Please subscribe to my channel and like this video. Bye.